Hello! In this episode, we reach the final frontier. We are moving to the vanguard of astrophysics. I will show you a hidden mistake that astronomers make. They don't realize that they are making a fatal mistake. This is about the redshift phenomenon and the Doppler effect. The redshift phenomenon will be discussed in detail. This is a shift of electromagnetic spectrum toward red. This phenomenon is intensified for distant astronomical objects. I will explain interaction between two physical phenomena. Interaction between redshift and dark energy. Dark energy is responsible for the redshift phenomenon. This is the truth. The Doppler effect cannot explain the redshift phenomenon. I will show you all these concepts. The Doppler effect and redshift are incompatible. The figure shows the dependencies. The redshift phenomenon is related to dark energy. This applies to distant objects. These elements are interconnected. They penetrate each other. Now, how is this connected? What does this look like? That's what I'm going to demonstrate to you. Astronomical observations show that the spectrum of distant objects is shifted towards the red color, redshift. A shift in the emitted wavelength spectrum towards the red. The picture shows the Milky Way. The second galaxy is very, very far from the first. The stars up here belong to the Milky Way. Each star has its own radiation spectrum. The spectral lines correspond to the elements and molecules in these stars. Spectral lines for distant stars are shown at the bottom. A distant galaxy and its stars. The spectral lines of distant stars are shifted towards red, redshift. For farther away objects, the effect is more intense. Redshift is bigger.
Przesunięcie ku czerwieni, czyli ten redshift.
It is important, very important, to understand the essence of the Doppler effect. This is the key to properly understanding the redshift phenomenon. Astronomers believe that the Doppler effect is responsible for the redshift. Edwin Hubble was the first to observe the redshift and the first to explain the phenomenon. That's how he constructed it. Distant objects move quickly, so their spectrum shifts. The reason for this is the Doppler effect. Now, the first star cruiser is moving at slow speed, low speed or zero. For the first cruiser, the Doppler effect is minimal or zero.
A zatem znikomy efekt Dopplera jest dla tego gwiezdnego krążownika.
At the bottom is a second cruiser that has accelerated to high speed. It moves very fast. Therefore, a large Doppler effect occurs.
Już istnieje efekt Dopplera, ponieważ szybko się porusza.
According to current theory, this is how it works. The Doppler effect increases with increasing speed. The same effect applies to stars. This explanation was provided by Edwin Hubble. He was the first.
obiekty,
I think so.
odległe gwiazdy
Distant
poruszają
objects,
się z dużą
stars
prędkością,
moving at very high speed.
dlatego posiadają efekt
A large
Dopplera
Doppler effect
i
occurs. The
w naszym
redshift
kierunku
phenomenon occurs.
ich widmo jest jakby przesunięte ku czerwieni.
Redshift increases with
Tym
distance.
większy, nim dalej się znajdują.
Same effect applies to stars. Same effect applies to star cruiser, right? If this is true for stars, then this is true for galaxies. Galaxies are clusters of stars. A distant star or a distant galaxy. It doesn't really matter. Only luminous objects produce a spectrum. They must be stars.
Odległych świecących obiektów, czyli gwiazd.
There are some inconsistencies in this logic. Distant stars are assumed to be moving at a high speed. This is the essence of Edwin Hubble explanation. There are flaws in this logic. They are shown here.
Tutaj je wymieniam.
Time slowing down according to Albert Einstein's special theory of relativity. Time slows down for fast-moving objects.
Bardzo szybko, już z relatywistycznymi prędkościami,
We can say that the internal time of the object slows down.
Spowalnia. Co za tym idzie?
There is also the Lorentz contraction.
Obiekt w kierunku lotu.
The object becomes shorter in the direction of movement.
Skrócony. Płaski.
A star has the shape of a ball. A fast-moving star changing its shape into a pancake, a flat disk. Many unpleasant consequences occur. Quantum effects slow down and fade away. All physical processes slow down. Quantum effects disappear. The fusion reactions stop. Photon emission stops. The stars can no longer shine. Many different problems arise.
Reakcje termojądrowe związane z emisją różnych cząstek, w tym fotonów, światła, to gaśnie słoneczna żarówka, ustaje świecenie gwiazd. Dużo problemów, całe mnóstwo problemów.
Fortunately, some astronomers predicted all this nonsense, and the explanation is that the Doppler effect sometimes exists, sometimes it doesn't. Astronomers sometimes explain that the Doppler effect is responsible for the redshift. Other times, astronomers say that the Doppler effect is not responsible for the redshift. The expansion of the universe is responsible for the redshift. This is what a star that moves at a relativistic speed would look like. No light emission. The star would look like a black hole. Similarly, for a galaxy. Galaxy will become black, completely invisible. Redshift does not exist. Completely lack of light emission. Darkness. List of problems: time dilatation, stopping quantum effects, Lorentz contraction, stopping thermonuclear effects, light emission off. There would be a great darkness. These are the consequences of the high velocity of stars. This is the beginning of a new understanding of this phenomenon. Astronomers now understand that the distant galaxies cannot move at a high speed. They absolutely cannot have relativistic speeds. The velocity of all galaxies must be small. The value of this speed should be similar to the speed of the Milky Way.
Czyli taką prędkość, jaką ma droga mleczna w przestrzeni kosmicznej, to mniej więcej taką podobną prędkość posiadają pozostałe galaktyki. Nie więcej, nie mniej, mniej więcej podobne prędkości.
So, where does the redshift phenomenon come from? You may ask, and you should ask. The redshift phenomenon cannot be explained by the Doppler effect.
Nie można stosować do wyjaśnienia redshiftu, czyli
Redshift exists and is observed.
przesunięcie ku czerwieni.
However,
Nie
galaxies move at a slow speed.
odpowiadać efekt Dopplera.
The difference in speed between galaxies is small. Often it is zero.
Działa tylko dla
The Doppler
szybko
effect
poruszających
is
się
the
obiektów.
difference in the speed of the objects.
Jeżeli
The
pojazd
Doppler
się
effect
zatrzyma,
will only appear
efekt
when there is a
Dopplera
large
powstaje.
difference in the speeds of objects.
Jeżeli
If
nie
both
możliwe
vehicles stop, the Doppler effect
aby
does not
odległe
exist.
galaktyki poruszały się w
It
lokalnej
is
przestrzeni,
impossible for distant galaxies to move at a high speed
a
in
jest to
local space.
niemożliwe.
This has already been explained earlier. The Doppler effect no longer exists for distant
Skoro
galaxies.
powstaje efekt Dopplera,
Doppler effect stop, redshift stop. However, the redshift exists and is observed.
istnieje
There has to be another explanation for the redshift phenomenon.
i nie może
There really is.
odpowiadać on
It's
za
not Doppler
przesunięcie ku
effect.
czerwieni. Niewykonalne. No oczywiście,
Dark
że
energy
ciemna
is a
energia
precursor
za to
to the redshift effect.
w jaki
How?
sposób?
I'll explain
No,
in
za
a
chwilę
moment.
wam pokażę.
Change of cosmological concept.
Kosmologicznej, czyli zmiana koncepcji.
Change the way of thinking. The first galaxy emits a photon.
Emituje
Let it be one
jakiś
blue photon.
foton, promieniowanie. Niech będzie jeden foton niebieski.
The photon has to travel a very long distance.
Zanim ten foton doleci do drugiej
It will
galaktyki
take a long
podległej,
time for photon to reach the
mało
second galaxy.
stopniowo zmienia
The
barwę.
photon gradually changes color until it reaches red.
Czerwieni, aż dolatuje jakiś czerwony foton.
We remember that in galaxies there are stars and planets that absorb dark energy.
Które zużywają ciemną energię.
They use this energy for quantum processes. Atoms are shown symbolically here. Atoms generate magnetic fields. Magnetic fields contain energy. Energy is absorbed. This is dark energy.
Zużywana jest energia ciemna na produkcję pól
It is converted at every moment into the energy of electromagnetic fields. The blue photon will leave Galaxy 1. The photon will reach Galaxy 2. This will take a long time.
Bardzo wiele energii też.
Both galaxies will absorb a lot of dark energy during this time. Dark energy will be converted into energy of the magnetic fields in atoms. The consequences of this process are simple and obvious. The level of dark energy is constantly decreasing. As time passes, the energy level decreases. This slide shows the process better. The first galaxy sends out a photon. A distant galaxy receives the same photon after a very long time. The photon changes its color. Energy levels have decreased. Dark energy level or vacuum energy level. Redshift is simply the loss of photon energy. This can be easily calculated.
Dość prosto pokazać na obliczeniach.
For example,
obliczymy sobie energię jakiegoś fotonu.
the speed of light and Planck's constant are physical constants.
To są stałe fizyczne, tak?
We should choose a photon wavelength. Let it be a blue photon. Wavelength lambda is 450 nanometers. You can take any value, of course. I choose 450 nanometers. Frequency is expressed by formula. This is the speed of light divided by lambda. Lambda is the wavelength. The energy of a photon is Planck's constant times the frequency. The energy of photon has been calculated. It is possible to calculate the energy for two photons. We can use another method. It is possible to calculate the energy of a single photon for two different moments in time. Times 1. Galaxy 1 emits a blue photon. Times 2. Galaxy 2 receives a red photon. It is just one photon, but at a different moment in time. The time difference is billion of years. You can take any values. I set the wave values as shown in the picture. The calculations are very similar to previous ones. First value for the blue photon, photon emitted by the first galaxy. Second value for red photon, a photon received by the second galaxy after a very long time.
Czyli czerwonego, tego, który dolatuje do odległej galaktyki. No i energię tego pierwszego
Energy of
fotonu
emitted photon.
I tego fotonu
Energy of received
drugiego,
photon.
tak?
The difference in values of these energies. Energy 1 minus energy 2.
Druga, mamy różnicę.
1% of the initial energy is calculated below.
Początkowej energii, po to, żeby sobie porównać, i różnica energii delta E
It is possible to determine the percentage energy factor. It defines the loss of initial photon energy, the energy difference delta E divided by 1% of the initial energy. In the example given, the photon has lost 40% of its initial energy.
Akurat dla tych przyjętych parametrów.
There are many different forms of energy. We remember, the energy of a photon is related to the energy of the vacuum. The level of dark energy decreases with time. The longer the photon travels, the more energy it loses. The galaxy contains stars, planets, and black holes. Dark energy decreases over time.
Ponieważ one niejako konsumują cały czas, bez przerwy, zawsze.
The vacuum energy is used to generate electromagnetic fields, orbiting electrons, quantum coils. It is schematically shown here. Another arrangement of this phenomenon. Galaxy 1 emits a blue photon. Galaxy 2 receives a red photon. The vacuum energy level decreases. This is not a stepped form, of course. Here is a bit deformed. It is easier to understand. In reality, the energy decreases very, very slowly and smoothly. You can imagine the situation. Water is down from the sea with a bucket. 10 buckets of water. This amount of water will not leave a visible mark in the sea. This loss of water in the sea can be observed because it's too small. If water is drowned frequently and for a long time, the entire sea will dry up. For example, 1 bucket of water every 5 seconds for the next 10 billion years. There will be no water in the sea. It takes a long time to notice this effect. A similar effect occurs with vacuum energy. Different arrangement of previous slide.
Poprzedniego slajdu, tak, żeby sobie to bardziej wyobrazić.
Dark energy truly is multifaceted.
Widzimy już teraz, że
the gravity of astronomical objects depends on the existence of dark energy. The level of dark energy determines the redshift. The value of dark energy has a direct impact on this process. Galactic integrity depends on dark energy. Quantum gravity depends on dark energy. Dark energy goes through many transformations. Dark energy transforms into gravitational energy. Gravitational energy must have an outlet. Gravitational energy is transformed into quantum gravity. A quantum coil produces a magnetic field. A magnetic field has energy. The level of dark energy determines the redshift. Redshift is like a fingerprint that indicates the level of dark energy. You know well that even King Solomon cannot pour from an empty vessel. He was a very wise man. It is a different thing to pour from a full vessel to an empty one, and a fool can do it. This is the principle of the loss of dark energy, zero field energy or vacuum energy. Energy is absorbed in quantum processes. That's how it works. It takes a lot of imagination to understand all this. Everything must be carefully considered and can also be checked using mathematical formulas. I will also show you computer programs. I will discuss them in detail and provide a link to the files. You will be able to calculate it yourself. Dark energy values for various astronomical objects. Practically, all 4 points have already been discussed. However, this is not the end of the information about dark energy. We still have some programming to do. I invite you to next episode. You have to watch and start programming. If you don't know how, I will show you everything in an easy way. Bye!
Cześć!